Hi students. So let me just switch it to today's material. So can you see this screen? Sungwon, can you see this screen? Won Sungwon, you wanna attend it? You are late today and you didn't even reply me. Let's take a look. Songchan, can you see the screen?
예,
Okay, so you how about Headin? Can you see the screen? Are you not using your microphone? Okay, Songchan, you are the audience of today. Okay, so I'll give you some bonus point for Songchan if you are actively replying to today's material. Okay, Songchan,
예,
do you know the meaning of audience?
예, 알고 있습니다.
Okay, so please turn on your microphone always, and you can reply me when I ask you something. I actually ask to students. Okay, so today's problem is free list. So the problem is very simple. You want to reuse the material. So if you have a linked list here, you allocated 3 items. Let's think about 3 items, A, B, and C. And C is the last item. So I'll use this notation for a null list. So you have A here, B as a second node, and C was stored in the third node. And this is your valuable data. So you may use this character list, CL. Okay, and you want to delete the first element. Then it is just you can just modify the link. So you can just modify the link to where? Songchan, should I modify this link to where? To here or here? To here. Okay, so you just broke the link and modified it to point to B. And then originally this node is deleted. Okay, this node is the target to be deleted, but you are maintaining the free list. So your free list, also called available list, free list is pointing to here, and this is set as null. Okay, so this is the concept of free list. So when you like to enter D, instead enter D before the B, you have to allocate it from your free list if it is not empty. So you can allocate this as D, and your pointer is also change it to link like this, and this is created as a new link. Okay, so you are maintaining a list of available nodes. Once it is allocated, if you'd like to delete it, you just push the node to the free list instead of deleting it. Okay, so pushing the free list is very easy, but I want to use it in a FIFO manner, because you have to implement queue instead of stack. So you may want to use this as a circular list. Okay, so let's think about, with the circular list, you are pointing to here, and your variable character list is pointing like this. Okay, so you also maintain your free list as a circular list. So if you have another node V was deallocated, you may maintain this as a circular list. Okay, so you have two queues to maintain. One is free list and the other is the actual linked list. So I'd like to mimic that free list using the array. So I have an array here. Okay, let's store this a little bit and delete all the entries. Okay, so I'd like to mimic this the free list using the array. So I'll give you a chunk of free array of nodes. So you have this as a static, and this chunk of free array is maintained by a free pointer. So free pointer is pointing to the available node. So once you'd like to make a new, you are examining that free pointer is available. So this current size is 10. You're just examining it with free pointer. So if it is available, then you can just return the address of this first element as the result. So you may return this one. So it seems complicated at first, but I'll show you free array and free pointer will be returned the address of free array of free pointer location will be returned. Okay, so this is the same meaning, but the free pointer is incremented after the return. Since it is not free anymore, you have to advance it. Okay, for these things, you just neglect this. You can use an error for that. Okay, so that means heap is full. So another thing is delete something. You just decrement the free pointer. For other things, you don't think about that. It is not an error. It is just another error if the free pointer is negative. Okay. So with this setting, you can make a node. So this is much like an unlock node, and this is much like a free node. Okay, so you'd like to print the current available free list here. So all the elements in the free array, it will be printed. And as you know, these two are the static elements. You have to make it initialize it as a variable like here outside of the class, and this should be initialized here. Do you know how this is in operation? Don't know? Okay, I'll just store this. I'll just save the figure. And let's take a look of another thing, the application code. So the operation code here is just allocating several nodes, and print it to the standard output. Okay, and the standard output will be printed, and the free list will be printed after each allocation, and some of it is deallocated. Okay, and after the deallocation, you like to allocate something. Okay, and it will be printed. So let's start this with your Visual Studio Code. So I show you the Visual Studio Code. Okay, so let me reshare this. Can you see this code? So before you start, I recommend you to install an extension, another extension, which is called Code Runner. So searching for Code Runner. So I already installed this, so you may try this. So the using Code Runner, it is supporting C and C++, so you don't need a complex management of making a build task or something. Okay, so please install this Code Runner. This is the more easiest one. So let me show you with a simple setting, just using a class node without a free list first. Okay, so let's copy all this. New node, how to make this is another thing. Long node, that's CPP. Long node, that's CPP. So you just paste this, and you don't want the free list here. Okay, so in a simple setting, you'd like to print it. Okay, you don't need this, and print free list is not needed. Okay, you are just making a node, and you don't like to print the data. Okay, this is not needed anymore. And this is the node pointer, and you can just make it as 5 or something. Okay, so you want to make 5 nodes. Okay, and you'd like to make a new node and store the pointer into the array, node array. Okay, and the data is printed here, and print free array is not used here, and you may delete some of them. Okay, you may delete some of them, and you may allocate some of them. Okay, allocate a new node starting from anyway, this is not needed anymore. Okay, just take a look. Okay, of this simple code. Okay, it is manageable. You just make a class, and in your main function, you are constructing the 5 pointers of this class, and you're allocating a new node starting from 1 to 5. Okay, each pointer is stored here, and you may also print them in reverse. From I is starting from 5, 4, I is greater than or equal to 0, I plus plus, and you'd like to make a print array I and print it with the C out. Okay, and you don't want to delete some part of it. Okay, so with this setting, you just once you allocate once you installed run code extension, you can push this. Okay, So can you see the 5, 1, 2, 3, 4, 5 is printed from here. From this 1, 2, 3, 4, 5 is printed from here. So you incremented it. So you have to decrement. Okay. So you have to decrement this, and then 5, 4, 3, 2, 1 should be printed. Save this and running this. So let's take a look. 1, 2, 3, 4, 5. 5, 4, 3, 2, 1. Okay. Is it good? Sangchan?
예.
He's not answering.
예.
Is it good, Dayon?
네, 좋습니다.
Okay. So let's make a free list here. Rather than allocating a new node, you can make node. Okay, so let's make it mk node. Okay, so you have to implement mk node for returning the array, returning the pointer of node. So let's think about that. Node pointer mk node. Okay, so you want to initialize it with a value. So integer data item into data is needed here. So how can I make this mk node? You can make a location. So node pointer p, new node with data, and return p. Is this good?
네, 좋습니다.
Okay, so let's execute this again. mk node was not declared in this scope. mk node. Did you mean node? Yes. This should be static. Okay, this should be static of mk node. So let's make this as static mk node, and you have to call this inside of it in the scope of node. Okay, node mk node. Okay, so it is making a node. Okay, so let's execute this. It seems good, but it is not visible enough. So you may print this. Print another auxiliary function, void star, receiving the number of stars. Okay, so while n is greater than 0, you just like to print it cout star. Okay, and n is decremented after that. Cout and line. So instead of printing here, so you may just call star with the array data item. Okay, so you just call this integer data item from here. Okay, and it is returning underscore data. So instead of this dummy print, you may want data, and you will use star. Okay. So this is more visible for reverse print. Is this good?
네, 좋습니다.
Okay. So rather than making a new node, you may want to an array static node, and you have free array with 5 items. Okay, so instead of allocating this, you want to, and this free array should be pointed static int free pointer etr, and free pointer value should be initialized as 0. So from the outside of it, so node type node free array is 5. So you may initialize this, but it does not need it here. And int node free pointer should be initialized as 0. Okay, so you have created two static variables. One is an array and the other is free pointer. And instead of this node pointer of our location, is just to make it the value of p is the address of free array of free pointer. Okay, and free pointer should be incremented after that. How about this? It seems good. It seems good, but you didn't initialize data. Okay, so you have to initialize it. P dot underscore data should be initialized as data. Okay, is this good?
네, 좋습니다.
Okay, so you are using a free array. Okay, so let's execute this. It seems good. Okay, it seems good. So when you need to, so before that, you have to check that free pointer should be greater than or equal to 0, and free pointer should be less than the size, which is 5. Okay, so if it is this, you have to allocate these things. So if it is not, then you have to make an error. Okay, for the error, you may throw -1, which is an exception. Okay. So if you want to try more than 5 elements, if you want to try to allocate more than 5 elements, this should be raise an error. So you may try this and catch an integer is not needed anymore, and you'd like to see error out of memory. Error out of memory. Is this good?
예, 좋습니다.
Okay, so let's try this. So you are allocating up to 5, but out of memory, and others are not executed. So if you want to try to exit or return 1, then the exit code will be changed. Okay, exit code is 1. Okay, is this good?
예, 그렇습니다.
Okay, how about free array? Static, void, free node. So the free node should accept a pointer. Okay, should accept a pointer. Mhm. But okay, the pointer should be a node pointer P, but it doesn't actually bring it. So you may just check it if P is equal to free the address of free array of the least one. Okay, free array of the free pointer -1. Okay, then this is very normal. Okay, but if it is not, you may raise another error. So it seems plausible for error code. So let's make a code int code -2 here. For this case, you'd like to make -1. So you'd like to throw error code. Okay. So this is another error. So in a wrong position of free. So if it is not, you just decrement. Free pointer is decrement. Okay. So this is the free node. So once you'd like to try free, your free should be performed from the last element. So let's rename this into J, which is J and J. Okay. So you are scanning it in reverse. But free should be performed for free node of array I-1 is valid. Okay. But free node, so node the free node, sorry. Node the free node. But free node of array 0 is not properly because it is not in the reverse style. Okay, so for the integer code, if the code is -1, then it is an out of memory as expected, like this. And if it is not, else, then the heap corrupted. Error. Heap is corrupted. Line, sorry, and the line return 2. Okay. It seems good. So let me just change this to be in operation. So let's make this 5. Okay, and this is normal. Okay, this is normal. Save this, and you may execute this using the code runner. Return 2 semicolon is submitted. Execute this again. 1, 2, 3, 4, 5. It seems good. And the last node last node is freed. Okay, so you may free this in the reverse style. Okay, so starting from while I is greater than 0, you may free I. Okay, so I should be decremented. I should be decremented before. So this is quite normal. Okay, so all the nodes are freed. But if you want to try to free, so this is normal. But if you want to try free this one, this is not normal. That is not in FIFO style, but LIFO style. Okay. So keep is corrupted. Is this okay for you?
예, 좋습니다.
Okay. Then last hurdle is that rather than the static method, you may overload operator new. Okay. So overload operator new. So void pointer, rather than make a node, you may want to make it operator new. Okay. And with this new setting, you have to this is fixed. Okay, size and the body size is fixed for that. Okay, so it is for allocating malloc or something. Okay, so but I will not use malloc, but just returning the pointer p. Okay, so you don't need this initialization. So this will be invoked automatically. Okay, and rather than the free, you want to make it void operator delete. And the operator delete is accepting void pointer p. Okay, so I just substitute operator new and operator delete as overloaded. So instead of this mk node here, you can make a new node. Instead of this free node here, you can make a delete array 0. Okay. So is this okay, Songchan?
네,
For the
좋습니다.
students? So let's execute this. Seems good. Heap is corrupted. This is normal because you are not deleting them in a proper order. Okay. So let's delete in a proper order. Okay. Then it is normal. So let's think about it. Let's rerun again. Quite normal. Okay. Okay, Songchan.
네,
Okay, good. So you may understand now. You may understand this program. This is very similar to previous program, and it is just make additional print for free node, and instead of raising exception, if it use the free pointer, then it is actually making a new node. So the actual new operator is used by the scope resolution operator. Okay, so if it is not cropped correctly, then you adjust free the node correctly. So if it is not, that means if it is allocated by these things, alloc 1, and you'd like to free it, dealloc 1 here. Okay, so for alloc 0, you'd like to deallocate with this one. Okay, that is just a tricky point. Rather than raising an exception, you are just checking another free area. And the free array is printed in an array. Okay, so once you adding some of the arrays, and then you'd like to delete some of them, and you can still make a star function if you'd like. So let's make a star function here. Star function if you'd like. Okay, so and instead of print it, you may want to return int data, return underscore data. Okay, then instead of print this, you may want to print data here. Okay, not print star. Sorry, star data here. Okay, so for now, you just neglect this. You just neglect this. Okay. So let's execute this. So single one is printed and one is allocated. 2 is allocated. 3 is allocated. Up to 10, 10 is allocated. Okay. And you'd like to free them in reverse order. So I is decremented and deleted. Okay. So you are freeing just 3 elements. But after that, you may want to try allocate another thing, another new node, and the value of this node is starting from 20. So 20, 30, 40, that will be printed. Okay. So let's execute this. Sorry, this is not matched. So let's rebuild it again. So up to 10, it is used up by the free list. Okay, but only 20 is used here. Okay, because the free array is currently up to 10. Okay, but if you want to make this as 10, then 3 elements, the first 3 elements will be used up here, like this, 20, 30, 40. Okay, so let's execute this again. Used up here, 20, this is current free, 30, and 40. Okay?
Yep.
Good. Okay, so do you have any other questions? So you know how to solve this problem, how to overload the delete and new. Okay, so let's switch it to the original problem. So today's problem is very simple. So this is a small note that the free array is so-called free array, and but the delete operation should be performed in LIFO style rather than FIFO style, FIFO style, because it is maintained by a single pointer, free pointer. And today's problem is free list CPP. So you are just making a free list using a queue. So you are implementing a data type using a free list, and data cell is entered into the free list when data is dequeued. In queuing the data, the program should examine the free list and use a cell if the free list is not empty. So if it is empty, you have to allocate it by new. So let's think about this simple sequence of operations. Okay, so let's use this. Okay, this sequence of operations. For in queue, you just make a queue 12. In queue, you just make another queue 27. The queue, you have to remove this. And in queue 31 should be entered. The queue, you have to remove this. You know how this is handled. Sangchan?
예,
Okay, so you have queue and you have free list. So once you have a queue of in queue 12, 12 is linked here. And entering 27, in queuing 27, 27 is included here. But once you'd like to execute the queue, you have to remove this 12, but that should be entered into the free list. Okay?
예, 이해했습니다.
In queue 31, then 31 should be entered here. The queue, this should be removed and entered into here. Okay? So this reflects the queue status and free list. Okay?
예,
So what happens? The free list is containing another element. So let me just decipher this in step by step. So the first operation, up to here, you may understand up to here. You may understand up to here. But once you'd like to dequeue this one, you have to remove this and push it to the free list. Okay? It is understandable up to this point, right?
예, 맞습니다.
Okay, good. So for the next step, I'll use another color. So you are understanding, you're understanding up to this point. Okay? But you'd like to include 31, but your free list is not empty. Okay, so you can reuse this as 31. Okay, so it is deleted from your free list. Understandable?
예, 그렇습니다.
Okay, so this was reused for 31. And dequeue means that 27 is removed from queue and push it into the free list. Okay, so you have to consider that your free list is in can be implemented in different way, but it is not here. You have to maintain your free list as FIFO way. Okay, so first element of the free list should be removed. So it is in queue style. Okay, so let's go into the today's problem. Your program should read from the standard input. The first line of the input contains the positive integer n, the number of q operations. The ith line of following n lines of input contains a single q operation, either inq or dq. The inq operation accompanies an integer as an operand, which is data. And your program should print to the contents of the queue and the free list after every stack operations. Therefore, the program output should contain two n lines, one line for the queue and the other line is for the free list. So as a final note, your program should assume that the queue is empty initially. So let's take a look of the input. So this first input is explained before. And let's take a look of this second one. So for in queue, your queue is containing 2. Okay? And your free list is empty at first. DQ means that it is moved to here. Okay? And in queue means you have to reuse this. You have to reuse this as 8. In queue means you have to allocate another thing, 29. Okay? And current free list is empty. And DQ means this should be moved into a free list, 8. And another DQ means this should be removed from here, 29. So the final contents is Q is empty and your free list containing 8 and 29. So you may understand these steps. Okay. Okay.
예,
Any questions? No questions? Then see you on the video lecture in the next week and next Wednesday. Thank you for all of you joining this lecture. 수고하셨습니다.